Hey everyone, Abby here with nursing.com. This lesson we'll talk about bicarbonate and what its normal values are, what increase and decrease values might mean, and also what is up with its relationship with CO2. Let's get started. Bicarbonate, affectionately called bicarb, is written chemically as HCO3. This lab measures the amount of bicarb in the form of carbon dioxide in the blood. Bicarb is a byproduct of metabolism. It's a base. Bicarb travels in the blood to the lungs and becomes exhaled as CO2. So there's a conversion. The kidneys, this is so important, kidneys are what regulate the excretion, the reabsorption, and the regulation of the acid and base, along with the lungs, right? But particularly it's the kidneys when we're talking about bicarb and acid-base balance. So it regulates the pH and the acid balance because of it being a base, right? And bicarb also works with sodium, potassium, and chloride. So you're going to see it on that lab skeleton of the electrolyte studies. It's going to be right here, reported as CO2. Some clinical indications are in the case of metabolic acidosis or metabolic alkalosis. Now, remember, we're talking kidney and we're also talking bicarb. So this is going to be metabolic. It's also evident or indicated rather in the case of kidney disease, liver failure, or any related metabolic dysfunction. It's all about the kidneys when it's metabolic. Normal therapeutic values, when it's drawn from a venous or used in a venous straw as part of electrolyte studies, are going to be between 23 and 30 milliequivalents. Remember, it's going to be reported as CO2 on that lab skeleton. It'll be right here. So let's say 29. Collection is going to take place in a plasma separator tube, like this green one here. When lab values are increased, it means metabolic alkalosis. But don't forget, this doesn't stand in isolation. This lab doesn't take into account the pH. We would need an ABG for that. But when we get it as part of an electrolyte study, it gives us this snapshot of acid-base balance. Now, it would be increased in a patient that has deficits of lung tissue, right? So COPDers, their lung tissue is spread and damaged, and so it's not exchanging gas as efficiently. And so that's going to, of course, lead to an excess of CO2. It can also be in the case of excessive vomiting because you're letting out all of that acid, right? And so it's leading to alkalosis. Loop and thiazide diuretics also affect the acid-base balance and the kidney's production of bicarbonate. In hypokalemia, this is evident because H+ or hydrogen shifts intracellular when hypokalemia is present, when all of that K also is going into the cell. And so therefore, we're in an alkalotic state. It's also going to be increased if there's an excess of mineralocorticoids like Cushing's syndrome or hyperaldosteronism. Decreased is going to mean metabolic acidosis. Now, this can get confusing. So remember the lab skeleton. This isn't an ABG. It would be opposite if it were an ABG. But if it's decreased on the electrolyte study, that's going to mean acidosis. That could be from diarrhea. Now, did you guys talk about this in school? We used to always say base out the butt. That helped us remember that is how bicarb gets wasted and leads to metabolic acidosis. It can also be because of an increase in acid production or retention. So the kidneys aren't able to excrete, right? So we're going to see that in reduced kidney function, whether that be acute or chronic. It could be an injury or actual disease. It's also evident in DKA, remember the acidosis part of DKA? It's because that fat is being metabolized into ketones, and ketones are acidic. It's also a part of lactic acidosis. That's going to be ischemia and other shock states that are going to cause a rise in lactic acidosis, therefore a rise in CO2 or a dip in bicarb, right? It can also be seen in aspirin or acetaminophen overdoses, and when the kidneys are trying to compensate for hyperventilation. But keep in mind, the kidneys don't keep up as well as the lungs. The linchpins for this lesson are that the HCO3 or bicarb is a byproduct of the body's metabolism. This lab value, as part of electrolyte studies, I'll draw the skeleton again, evaluates for CO2. That's how it's reported. They're one and the same when it's a venous draw. Normal values are between 20 and 30 milliequivalents per liter. If it's increased, we can say there's metabolic alkalosis. Something is reducing the acid. If it's metabolic acidosis, something is reducing the base, right? Now, I know that can get a little confusing, so hopefully this clarified things. You all did a great job on this lesson, and this wraps it up. You can do it. And remember, go out, be your best self today, and as always, happy nursing.